So moving on, this is level 3. So level 3 problem, we're actually, this is actually going to be a dynamics problem. They're no longer staying still. We're going to actually assume M3 is greater than M1. These are pulleys over here, by the way, if you didn't realize. And so since they're all connected, M3, oh no, okay. Since they're all connected, M3 is going to pull down, and that's going to pull on M2, and M2 is going to pull on M1. And since they're all connected by a string, they're all going to have the same acceleration. That is an important thing to keep in mind. So the whole system has one and one only acceleration. So that they're all going to have the same acceleration, and that's going to depend on let's do a force analysis. So as always, you put down what the weights are, so M1g and M3g. We're assuming going to the right is positive. Anyways, so we've got these, and if you're thinking, well, Aishi, shouldn't there be a M2g acting downward? You're right, I just forgot to animate that in, but like, we'll talk about it later anyways, so don't worry about it. It doesn't matter right now because there's no friction. Anyways, so there's one whole string over here, and tension kind of acts inward, so T1 acts on both M2 and M1, and it kind of acts inward. Same goes for the second string, so T2. So there's only two tension values, and this whole thing can actually be redrawn like this. It's just in a chain kind of setup. So you can see M1G all the way to the left, and M3G all the way to the right, and T1s face each other, and T2s face each other. Alright, anyways, let's find the acceleration of the system. Since they're all connected by a rope, or a string, or whatever you want to call it, since they're all connected, they're going to have the same acceleration. You can't just have one thing accelerate at a different speed from another if they're connected. You know, if you're holding hands with your best friend and running away, and if you're like super fast, but your friend is super slow, and she doesn't ever want to run with you, then you're gonna break apart, and you're no longer gonna be a system. Anyways, finding the acceleration of a system, so okay, so this is Newton's second law, F net equals ma. And so F net equals ma, so we're gonna apply it to the whole system. So the t's will cancel, because we're trying to find F net, so we have to figure out which forces to focus on. So we've got, what's left is so they're canceling because they're kind of facing each other and just doesn't matter. So the forces that we're left with are M3G and M1G over here. So F net is equal to M3G minus M1G. That makes sense. Next is going to be M net. So we're trying to find M net for this M part over here. I didn't want to write M net A because it won't let me do subscript for some reason. Anyways, M net of the whole system is going to be M1 plus M2 plus M3. So far we have the force applied on the system as a whole, and we have the mass of the system as a whole, M1 plus M2 plus M3. Now we can just solve for A. So A is going to be equal to F net over M net. You know, you can just rearrange this equation, and you can solve for acceleration of the whole system. This is the acceleration for M1. This is the acceleration for M2. This is the acceleration for M3. They all accelerate at the same rate. Alright, so let's continue. So usually, okay, so we're going to find individual tension now. So usually, you can't just end it at finding acceleration. You got to find tension as well because they want to add more steps, but that's okay. Since you already know the acceleration of the system, it's going to be the same for all masses. So to find individual tension, you're going to focus on the FBD, free body diagram, for one mass to find the tension. For us, we want to find T1, so we're going to focus on M1 since it has T1 in it. and if you just ignore everything else, there's just two forces acting on it, m1g and t1. And f net of m1 is going to be t1 minus m1g. It doesn't matter if you put m1g first or t1 first. I'm assuming going to the right or going upward is going to be, yeah, so going to the right or going upward is going to be positive. So I put t1 minus m1g. That's the f net of m1. We also know that the f net of m1 is going to be m1 times the acceleration of the whole system. So now we have two equations, and since these two are the same, we can actually set them equal to each other. So t1 minus m1g equals m1a. If you're trying to figure out where I got the m1a from, it's literally just from the acceleration of the system that we calculated before. That's why we need to calculate the total acceleration of the system. And, then multiply by the mass of the individual. Alright, so now we have this equation. You just rearrange, and voila, you get t1 equals m1g plus m1a. If you're getting bored, stay with me, please. We're almost to the end. We have 4 levels. We're gonna complete this. All right. One last thing that I have to mention for level 3 is oh, there we go. She didn't fail you. She was just saving the MG for last. She's not wrong. There's an MG here. And it finally comes in because we have a FF. We have a force of friction. Okay, so you must be wondering, Aishi, if there's an MG here, wouldn't that just go downward? Well, you're right, but actually there's a force normal upward. You know what? Alright, there, you happy now? There's a FN now. Okay, fine, okay. Good. She is never wrong. Okay. Anyways, so since there's an MG actually here, there's going to be a F normal acting on it, and if we assume this is not a frictionless plane, what an amateur, not being frictionless. Okay, but there's going to be a force of friction acting acting this way if you're moving to the right, which we are assuming it is. So that translates to, oh my god, okay, nope, go back, stop it. Okay, that translates to this chain kind of diagram like that. There's a FF as well acting, so incorporating friction. FF, so force of friction, as you know, is equal to mu Fn. Mu is going to be given to you. It's going to be dependent on the material that is acting on your object, and it's going to be mu mg because Fn is going to be equal to mg because m2 isn't digging into the earth or floating upward. So Fnet of the whole system is going to equal m3g minus m1g minus F force of friction, because the t's again cancel, and if this stupid thing, okay, no, it's never going to go away. So there's m3g here, m1g here, the tensions will cancel, and you can't see it. Okay, there's a force of friction right here, and it faces backward, it faces to the left. So m3g minus m1g, because that goes to the left, and minus ff, that goes to the left. So that's your F net for the system. Now, and from there you can figure out the other stuff. The M net is going to be m1 plus m2 plus m3 as always. And then you can find the acceleration of the whole system. Okay, other level 3 questions might be at-one machines or pulleys. Again, just m1, m2. So F net is going to be equal to m2 minus m1g, m2g minus m1g, because, I mean, I made m2 look bigger, though they're usually going to tell you or indicate which way it's moving, either by telling you the mass is outright or just, just telling you, hey, it moves to the right. And acceleration is going to be F net, so which is m2g minus m1g, over m1 plus m2, this stupid little, go away, okay. And so you can find the acceleration that way. On inclined planes, it's gonna be F net, so, okay, did I do any, oh, no, I didn't do anything. Alright, so this black line here is gonna be mg, because it acts straight downwards on this block. Right. Okay, so, this black line is gonna be m2g, and, this, green over here, this green line over here, if we know the theta of the incline over here, we know that there's a theta between, the line that goes perpendicular to the surface and the line that, is the vector of the force of gravity. The theta between those two lines is going to equal this theta, and since this green line, it's opposite to this theta, it's going to be m2g sine theta. Since m2g is the hypotenuse, this here is going to be the right triangle. So F net is going to be m2g sine theta. That's going to, because m2g is acting this way, and you're going to subtract m1g from that. I don't feel the need to elaborate very much on this. Just imagine it like, just imagine it in that chain kind of diagram way. Just draw out the blocks, draw it out horizontally, ignoring, all the direction changes of the pulley, because all the pulley does is it